This material explores why 95% of enterprise AI projects fail to reach production due to disconnected architectures and argues for embedding agentic AI directly within business systems.
It's a really fascinating premise, isn't it?
Oh, absolutely. The submission is undeniably strong and, really persuasive. It leverages excellent data like the MIT Project Nanda research.
Yeah, the data foundation is rock solid.
But this critique will focus on pushing past those theoretical ideals to address the profound friction of real-world implementation.
I completely agree. I mean, the foundational arguments are incredibly sharp, and the vision itself is compelling.
Right.
But if we want this piece to truly resonate with enterprise leaders and the technical architects who are in the trenches every single day, we need to stress test the operational realities of what's being proposed.
Yes.
We really have to look at the grime on the gears, so to speak.
Exactly. So let's start at the foundational layer, how the material frames the storage and architecture of enterprise data before the AI even touches it.
Okay, yeah.
As I understand it from the notes, the argument here is that third-party overlays in data lakes destroy business context?
Mm-hmm.
The author points out that when you pull data out of a core system, you lose the business hierarchies, the currency relationships, the transactional dependencies.
You lose the gravity of it.
Yeah, you really do. And for our listeners who might not be in the weeds here, a zero-copy architecture basically means the AI analyzes the data exactly where it sits in the database.
Right, no moving it around.
Right, you don't have to duplicate or move the data to a separate lake to work with it. And the author makes an excellent point about why moving it is so destructive.
It really strips the meaning.
It does. I mean, it's like taking a meticulously organized library, dumping all the books into a massive pile in a warehouse, and burning the card catalog.
Oh, wow. That's a great way to put it.
Yeah, because you still have all the information, but the semantic relationship between the texts is completely gone.
That is a highly effective way to visualize the problem of semantic degradation.
Yeah.
The text does a masterful job of diagnosing why simply relocating data makes it harder to trust.
Mm-hmm.
That's clearly laid out. I wonder, though, if we've considered how this operates outside of a vacuum.
I can see what you're going for here. Let's see how we can strengthen this part of the argument.
Well, the critique of the third-party overlay model presents a compelling case, but it risks oversimplifying the operational realities of legacy enterprise architectures.
Okay, how so?
The weakness here is that the material paints zero-copy architectures and data fabrics, where AI analyzes data directly in systems like SAP S/4HANA, as this frictionless, almost binary alternative to the data lake model.
Ah, I see.
It essentially ignores the messy reality that the vast majority of global enterprises do not possess a single pristine ERP environment.
Right, it's never just one clean system.
Exactly. Instead, they're managing a tangled web of fragmented, highly customized, and often competing legacy systems.
Hold on, but isn't the entire premise of a modern data fabric to lay over top of that exact mess and act as a universal translator?
Technically, yes.
Because the author seems to imply that the AI will just natively understand the disparate systems once it's embedded.
Right. Conceptually, a data fabric is supposed to stitch it all together, but the text treats this as if the enterprise environment is a clean slate.
Which it never is.
Never. Or it assumes it's at least a highly modernized ecosystem that natively speaks REST APIs and GraphQL.
Yeah, and that's just not true for most places.
The reality on the ground is far more chaotic. If you are advocating for activating intelligence exactly where the data lives, well, you have to account for the fact that the data might live in 3 or 4 entirely different places.
Speaking fundamentally different architectural languages.
Exactly. The AI can't just think its way into a closed system.
That's a very fair point. You can't embed an agent into a system that doesn't have the door built yet.
Precisely. So the suggestion to elevate this argument is to firmly ground the piece by acknowledging the messy middle.
The messy middle. I like that.
Yeah. The material needs to explicitly address the friction, the engineering hurdles, and, honestly, the massive transition costs associated with shifting from a highly fragmented legacy state to a true, seamless zero-copy architecture.
So a key theme running through this material seems to be the contrast between architectural theory and operational practice. What are some concrete examples the author could use to flesh out this transition phase and show they understand the pain of the messy middle?
A fantastic concrete example would be to introduce a scenario involving corporate mergers and acquisitions.
Oh, that's perfect. Mergers are always a nightmare for IT.
Exactly. The author should discuss exactly how this zero-copy embedded AI model functions when an enterprise is running three different conflicting ERP systems resulting from recent acquisitions.
Right.
Let's say Company A uses a modern cloud-based SAP instance.
Okay.
Company B uses a heavily customized on-premise Oracle database, and Company C, which they just bought for its manufacturing footprint, relies on a 25-year-old homegrown AS400 mainframe sitting in a server closet in Ohio.
Oh, man.
Right, and that AS400 doesn't have modern APIs. It probably only processes flat files in nightly batches.
Exactly.
So how does an autonomous agent natively trigger a real-time workflow across a modern cloud API and a mainframe that only wakes up once a day to process a text file?
It can't. Not natively.
Right. If there is no integration layer, because remember, the author argues against third-party overlays, how does the agent operate directly within that workflow?
That's a huge gap.
The author needs to explain the mechanics of the data fabric in a highly imperfect, highly latent environment.
That immediately grounds the piece in reality. It forces the text to explain the nuts and bolts of the transition.
Absolutely.
And what about unstructured data? Because the text heavily penalizes data lakes because they destroy the relational context of financial transactions.
Mm-hmm.
But an enterprise isn't just ledgers. It's also, millions of PDFs, supplier emails, contracts, and external market data feeds.
That is another perfect, concrete example for the author to include. The text could explore whether data lakes might still hold temporary or even permanent value for non-transactional, unstructured data, while the enterprise works toward this idealized data fabric model for its core financials.
So like a hybrid approach?
Yes, exactly. Is there a hybrid stepping stone where agents pull relational context from the zero-copy ERP, but pull text analysis from a traditional data lake?
That makes total sense.
Addressing that hybrid reality makes the piece much more robust and much more credible to a chief data officer.
Yeah, it shifts the argument from a utopian technical vision to a pragmatic, actionable roadmap.
Exactly.
So, assuming an organization successfully navigates that messy middle, modernizes their legacy systems, and gets their underlying data architecture right, the material suggests the next leap is moving from a chain of thought to a chain of action.
This is where it gets wild.
It really does. Let's look closely at the section discussing the idea of agents triggering invoice corrections and ledger adjustments.
It is a massive proposition. The text outlines agents independently triggering these corrections, making ledger adjustments, and executing financial controls without human bottlenecks.
It is a massive proposition. And frankly, as a reader, this is where my skepticism really flared up.
Oh, really?
Yeah, because the material states that to maintain trust in these automated actions, modern agent architectures rely on cryptographically verifiable identities and audit trails.
Right.
The argument is that because every single action is mathematically traceable and locked on a ledger, a CFO will implicitly trust it.
I see where you're going.
But I have to ask, is relying purely on cryptographic audit trails genuinely enough to overcome a CFO's deep-seated anxiety about an AI touching the general ledger? I mean, an immutable, mathematically perfect log of a disastrous automated financial error is still a disastrous error.
That makes sense, but could the evidence also support a different conclusion? Like the idea that technological trust does not automatically equate to cultural trust?
I think that's exactly where the disconnect lies.
Yeah. The transition from chain of thought to chain of action is presented as a logical technical evolution, yet it underestimates the profound risk aversion inherent in enterprise compliance cultures.
It really underestimates it.
The fundamental weakness in this section is that it relies exclusively on technological solutions, specifically cryptographic identities, tamper-proof logs, and traceable audit trails, to solve what is ultimately a human, psychological, and cultural hurdle.
Yes.
The lack of trust in automated financial controls is not just about whether an action is verifiable. It's about the visceral fear of relinquishing control over the financial lifeblood of the company.
Right. A cryptographically verifiable trail solves the math problem, but it ignores the psychology.
Completely ignores it.
It tells the CFO exactly how the AI made a mistake down to the millisecond. It proves the AI had the authorization to make the error, but it doesn't prevent the CFO from losing their job over that mistake.
Exactly.
The human element of trust, the fear of accountability without control, is entirely missing from the equation the author presents.
Exactly. You cannot code away human anxiety with a SHA-256 hash.
No, you can't.
Therefore, the suggestion to elevate this piece is to deepen the analysis by bridging the gap between AI-generated insights and full autonomous action.
Okay.
The author needs to explore the necessary transitional phases of human oversight. You don't jump straight from a manual Excel spreadsheet to a fully autonomous financial controller without a significant period of training wheels.
The training wheels are essential.
Right. The organization needs to build psychological muscle memory.
Okay, so what I really like about this part is that we can provide some very specific architectural stepping stones to help the author build that bridge.
Yes.
What are some concrete examples the author could weave in to illustrate this cultural transition while still utilizing the advanced agentic technology they are advocating for?
Well, a highly effective concrete example would be to propose a human-in-the-loop intermediate step within the architecture.
Human in the loop. I like that.
The author could describe a workflow where an AI agent detects a cross-border tax anomaly, gathers all the historical context from the zero-copy database, and actually prepares the entire ledger adjustment.
So the AI does all the heavy lifting.
It does 99% of the heavy lifting, but crucially, the system is hard-coded to require a one-click human approval before execution.
Ah, okay.
The text can frame this not as a failure of automation, but as a deliberate, necessary phase to build trust over time. The CFO gets to see the AI be right 1,000 times in a row before they finally decide to toggle the system to full autonomy.
I love that. The human acts as the final gatekeeper until the organization is culturally ready to let go.
Exactly.
And what about the auditors? Because the text leans so heavily on these cryptographic trails as the ultimate proof of compliance.
Right.
But how does a human auditor even interface with that? I can't imagine a traditional internal auditor is going to open up a command line and start verifying Merkle trees.
No, they absolutely aren't. And that is the second perfect concrete example. The author needs to explore how regulators or internal auditors actually interact with these cryptographic audit trails during this transitional phase.
Yes.
Because it's one thing to say the immutable trail exists, it's another entirely to explain how an auditor digests a machine-generated cryptographic hash.
Right. It needs a translation layer.
Exactly. By describing the user interface, the translation layer that makes these complex mathematical proofs legible, visual, and comforting to a human auditor, the piece would demonstrate a much deeper understanding of the human-technology interface. The author needs to explain how the math gets translated into a dashboard that a regulator can actually read and sign off on.
That single addition changes the entire tone of the section. It moves it from a purely technical manifesto to a sophisticated guide on organizational change management.
It really does.
It acknowledges the fear of the end user and provides a practical interface-driven mechanism to soothe it.
Exactly.
Which brings us to the ultimate evolution described in the piece. So, if a CFO eventually trusts one agent to make a ledger adjustment, with or without human intervention, what happens when there are dozens of these specialized agents operating at once across the enterprise?
The ecosystem layer. The text introduces this as the Internet of Agents.
Yes. The material makes a strong case for an Internet of Agents collaborating across distributed systems for complex, multi-layered tasks like real-time VAT analysis, cross-border transaction intelligence, and continuous regulatory monitoring.
It's an incredible vision.
It sounds incredibly powerful, but my immediate reaction reading this was, it sounds like a brilliant orchestra composed entirely of prodigies. But who is the conductor?
That's a great question.
Like, who is keeping time? And what happens when the brass section decides to play a completely different song than the strings?
That is a phenomenal analogy, and it leads us directly into our final area of critique. Building on that point, what if we looked at it from the perspective of systemic orchestration and conflict resolution?
Let's do it. It feels like the author has built a highway with no traffic lights.
Right. The vision of an Internet of Agents collaborating across distributed systems is fascinating, but it leaves a critical gap regarding overarching orchestration and conflict resolution.
It's a big gap.
The weakness here is that while the text beautifully describes specialized autonomous agents communicating through standardized protocols, it completely fails to address what happens when these agents logically conflict.
Yeah, they're bound to conflict eventually.
It ignores the risk of cascading errors or deadlocks across a highly connected, high-speed network.
That is a massive blind spot for any enterprise architect reading this. I mean, in any complex adaptive system, components will eventually work at cross purposes.
Exactly.
If you have dozens of micro-intelligences acting independently, pulling from different datasets and pursuing different localized goals, collision is a mathematical certainty, not just a theoretical possibility.
Exactly. And if you remove the human bottleneck from the workflow, you also remove the human common sense that typically resolves those nuanced collisions.
Yes.
So the suggestion for the author is to introduce a supervisory framework or a clear mechanism for agent orchestration.
Okay.
The material needs to explicitly detail how the system handles disputes, prioritizes conflicting mandates, and ensures overall systemic stability when the agents inevitably disagree on a course of action.
This is where we need to get very specific to help the author visualize the gap. What does an agent collision look like in the context of enterprise finance, and how can the author illustrate the technical solution?
Well, a great concrete example would be to detail a specific scenario involving two competing agents working on the same transaction.
Okay, set the scene.
Imagine a massive $50 million cross-border payment. A VAT analysis agent has just attempted to process and validate the transaction to ensure real-time tax compliance across 3 different jurisdictions.
Got it.
It runs its calculations, finds everything in order, and attempts to execute the payment. Simultaneously, a financial risk detection agent flags the secondary counterparty in that exact transaction due to a sudden, real-time shift in global sanctions data that occurred 4 seconds ago.
Wow.
The risk agent immediately attempts to halt the payment.
So the tax agent is literally issuing a go command to the ledger, and the risk agent is simultaneously issuing a stop command to the exact same ledger entry.
Exactly. How do the standardized protocols mediate that deadlock? Does the risk agent have hierarchical supremacy built into its core logic?
That's a great question.
Does the system automatically freeze the transaction and escalate it to a specialized supervisor AI? Or does it drop it into a queue for a human compliance officer?
Right.
Walking the reader through the exact resolution of that specific conflict, explaining the hierarchy of the protocols, would add immense credibility to the concept of the Internet of Agents.
It shows that the author isn't just dreaming up a theoretical network, but has actually thought through the fault tolerances and the dispute resolution layer of that network.
Exactly.
But I have a piece of pushback here.
Okay, sure.
If we introduce these dispute resolution mechanisms, or as the author might call them, circuit breakers, aren't we just reintroducing the exact same bottleneck the AI was supposed to eliminate?
That's a fair point.
I mean, if every time agents disagree it trips a circuit breaker and requires an escalation, we're back to a human having to clear a massive backlog of flagged transactions, doesn't that defeat the purpose?
That is the exact tension the author needs to address. And it brings up a second crucial example. The author needs to outline what a systemic circuit breaker actually looks like without breaking the business.
Okay.
The piece mentions that compliance shifts to an always active capability, generating automated audit evidence continuously. But what happens if this network of intelligent systems begins generating contradictory continuous compliance data?
Right, a feedback loop of errors.
The author should describe a systemic kill switch or circuit breaker that pauses autonomous execution but does so through graceful degradation.
Graceful degradation.
Yes, meaning it isolates the short circuit without shutting off the power to the entire house.
Ah, I see.
If the VAT and risk agents are stuck in an infinite loop of validating and freezing a specific subset of transactions, the protocol shouldn't crash the entire ERP or stop all global cash flow.
Definitely not.
The author needs to explain how the system isolates that specific functional node, reverse it to a localized, safe state, perhaps falling back to rule-based logic or human oversight, while the rest of the enterprise network continues operating at light speed.
That makes a lot of sense.
Giving enterprise leaders that targeted emergency brake is absolutely crucial for making the Internet of Agents a palatable, safe concept.
That is incredibly clarifying. It addresses the systemic risk that naturally emerges from hyperautomation, and it answers the business reality of what a frozen transaction actually costs.
Yes, exactly.
By detailing the orchestration layer, the hierarchical logic for conflict resolution, and the mechanisms for graceful degradation via circuit breakers, the text evolves from a conceptual pitch into a rigorous, battle-tested architectural blueprint.
And that rigorous blueprint is exactly what the target audience of enterprise leaders, CFOs, and technical architects is hungering for. They already know the theoretical potential of AI. They are reading this material because they need help navigating the hidden hazards of actual implementation.
Well, we've covered a tremendous amount of ground today, and I think we've provided some deeply architectural and psychological layers to add to this already stellar submission.
It really is a great piece.
Let's summarize the 3 actionable areas we've discussed today to elevate this piece. First, when advocating for zero-copy architectures and moving away from data lakes, the author must address the messy reality of legacy systems, acknowledge the friction of the transition, and explore how this embedded AI model functions amidst conflicting, fragmented environments like a mix of modern cloud APIs and legacy mainframes.
Second, to bridge the profound cultural trust gap in the chain of action, the text should introduce human-in-the-loop transitional steps. It's vital to show how organizations can build psychological trust by requiring human approval for AI-prepared actions, and by designing user interfaces that translate complex cryptographic audit trails into legible formats for human auditors.
Finally, the vision of the Internet of Agents needs a conductor. The author must define the governance, the hierarchical logic, and the dispute resolution mechanisms required to prevent cascading errors when autonomous agents inevitably collide over competing mandates, and explain how circuit breakers can provide graceful degradation without crashing the enterprise.
Implementing those structural layers of nuance will make an already strong, data-rich argument absolutely bulletproof.
The foundation of this piece is exceptional. Addressing the friction of the real world is simply the final polish.
Absolutely.
We want to sincerely thank the listener for submitting such robust, thought-provoking material. We invite you to implement these recommendations, tackle that real-world friction head-on, and submit your revised work back to the critique for further feedback. Because while theoretical perfection is appealing, it's the messy, complicated realities of implementation that truly transform an enterprise.